Welcome back! Today we are going to go over the distance formula. Our content objective is students will be able to use the distance formula to find the distance between 2 points in a coordinate plane. Language objective is students will be able to explain how to use a distance formula. And why am I learning this? Well, it's important for finding the distance from one place to another. First, going over some background knowledge. From our previous lesson, we went ahead and graphed 2 points, drew in our line, and created a right triangle. And from there, we were able to apply the Pythagorean theorem and find the distance between the 2 points, which essentially was the hypotenuse. So that is going to come into play today with the distance formula. So here, let's think. If we were given 2 points that were maybe very large numbers or decimals, ideally, would we want to put it on a graph and do the same thing that we did in the previous slide? The answer is no. Plotting on a coordinate plane is not always the best option for finding the distance between 2 points because maybe your ordered pairs are too large again, or maybe your points are not whole numbers, so that's going to be a little bit difficult to do. So there's something called the distance formula. The distance formula is really nice if you don't want to plot ordered pairs because maybe you don't have graph paper handy, you don't have to draw your triangle and use Pythagorean theorem. So let's go ahead and take a look on what the distance formula actually is. So here, let me just go ahead and give you an example of 2 ordered pairs, which I'm just going to call x sub 1, y sub 1 for the first ordered pair, and x sub 2, comma, y sub 2 for the second ordered pair. So if I want to find the distance of this line, I'm just going to call it any variable I want, which in this case is a capital D. So first understand this, that the distance formula is technically derived from the Pythagorean theorem. So here is the height of my triangle. How do you figure out the height? Well, that's essentially the rise, which is aka is the change in y, the axis that runs up and down. So here, in order to find the height of it, I'm going to go ahead and find the difference between how did y sub 1 become y sub 2. So that's y sub 2 minus y sub 1. You simply find the difference. Well, here is the other length of the right triangle. So that's basically a line that runs horizontal. So what ordered pairs, which coordinate tells me the length that runs from left to right? That's going to be the x-axis. So I'm trying to figure out the change in x sub 1 to the change in x sub 2. So in other words, you're going to find the difference between the two x's, so x sub 2 minus x sub 1. So here, let's go ahead and plug this into our Pythagorean theorem. So we have our a squared plus b squared equals c squared. I went ahead and put c squared up front. Okay, it's not a big difference. So here, c squared, what I'm going to replace c with is this capital D. So now we have d squared equals, what is a squared? Well, here's one of them, x sub 2 minus x sub 1. And then what about b? Here's the other leg, so I'm going to go ahead and add that to y sub 2 minus y sub 1. So we're almost done, but remember we only want to figure out the length of d by itself, not d squared. So what I'm going to have to do is take the square root of both sides, like so, which is going to leave me with d equals the square root of the change in x's squared plus the change in y's squared. So this here, I know it's a little intimidating because it's pretty lengthy, but this is your distance formula. Please understand the distance formula is derived from the Pythagorean theorem, so if anything fails, please go back to drawing a right triangle, figuring the height, figuring the width of the right triangle, and go from there. Okay, so let's go ahead and practice using the distance formula. So here, in our first example, it says use a distance formula to find the distance between the coordinates below. So first, you got to practice writing that distance formula. It's going to be d equals the square root of the change in x's, so x sub 2 minus x sub 1 squared. That's basically representing the a, plus the b, which is going to be y sub 2 minus y sub 1 squared. So here's my a squared, here's my b squared. So all you're going to have to do is label the different ordered pairs. Here's x sub 1, y sub 1, x sub 2, y sub 2. So plugging into the formula, I'm going to get distance equals the square root of x sub 2 is 9. So I'm going to do 9 minus, make sure you put minus, x sub 1, which is 1. So I'm going to square that and add that to y sub 2, which is 10, minus y sub 1, which is 4, and square that as well. So now I'm just going to go ahead and continue to simplify. 9 minus 1 is 8. So now we have 8 squared plus 10 minus 4 is 6, and then I'm going to square that. So notice I had to simplify within the parentheses first before I have to square the numbers. So now I should have the square root of 64 plus 36, which is going to leave me with d equals the square root of 100. I'm not finished quite yet. The square root of 100 is technically plus or minus 10, but since we're talking about distance, I'm just going to go with the answer of 10. So to answer the question, the distance is 10 units. Since there isn't any units given, I'm just going to go ahead and say the word units. Okay, so that's all there is to it. So the biggest thing is practicing that distance formula, having it memorized, but also understanding it is derived from the Pythagorean theorem. So in other words, you're finding this here represents one of the legs squared. This one represents the other leg squared. You're just finding the length by finding the difference or the change in x's and the change in y's. Number 2, again, you got to first start with writing down the formula. D equals the square root of. First, you're going to have to find the lengths of one of the legs. So let's find the difference in the x's. So x sub 2 minus x sub 1 squared. Add that to the length of another leg, so that's going to be the change in the y's, so y sub 2 minus y sub 1 squared. At this point, it's going to be helpful if we label each of the ordered pairs. I'm going to call this x sub 1, y sub 2, y sub 1. Then we have x sub 2 and y sub 2. Now at this point, I can go ahead and plug in my values into the formula. X sub 2 is negative 8. Make sure you put minus. X sub 1 is 4 squared plus y sub 2, which is negative 12, minus y sub 1, which is negative 7. That's where you're going to have to be very careful. Again, a lot of students are just going to have the tendency of just putting minus 7 instead of minus negative 7. So please be mindful of that. So at this point, I have d equals negative 8 minus 4. If you add the opposite, you end up with a negative 12 squared. Plus, here, if you add the opposite, you have negative 12 plus 7, which is a negative 5, and you're going to square that, leaving me with d equals negative 12 squared is 144, plus negative 5 squared, which is 25. I'm going to be left with d equals the square root of 169, which simplifies to just 13. So what's the distance between these 2 points? I would say it is 13 units. So that's all there is to it, making sure you've memorized the formula, know how to plug the numbers in, making sure you don't accidentally neglect the minus negative. Other than that, you're good to go. So at this point, what I'd like you to do is go ahead and pause the video so that you can try numbers 3 and 4 on your own. Okay, so let's see how well we did. So for number 3, first write down the formula. Second would be to list which ones are x sub 1, y sub 1, x sub 2, y sub 2. And then simply plug it into your formula. So here you should have gotten the square root of 3 minus negative 3, you got to be very careful with that, squared plus negative 2 minus 6 squared, which leaves you with here, if you add the opposite, you do end up with a 6 squared. And here, if you add the opposite, you do end up with a negative 8 squared. So now I'm going to simplify this one step further. 6 squared is 36, negative 8 squared is 64. Add those two numbers together, you end up with d equals the square root of 100. So therefore, the distance is 10 units. Okay, so hopefully you got that one correct. Let's go ahead and check and see how well you did with number 4. Same thing, you're going to first start with the distance formula, which is d equals the square root of the change in x's, so that's x sub 2 minus x sub 1 squared, plus the change in y, so y sub 2 minus y sub 1 squared. So now I'm going to go ahead and list which ones are the x sub 1s, y sub 1s, x sub 2, y sub 2s. Plug it into your formula, and then simplify it from there. Here, we're going to go ahead and add the opposite, which is going to leave us with a negative 9 squared. Here, if we add the opposite, we're going to end up with negative 12 squared. Negative 9 squared is 81. Negative 12 squared is 144, leaving me with the square root of 225. Hopefully at this point you recognize that that is 15. So what is the distance between these 2 points? I would say the distance is 15 units. Okay, so now let's go ahead and practice some more. So now we're going to go ahead and practice with numbers where it's not a perfect square. What are we going to do? Okay, so first things first, let's start with the formula. D equals the change in x, which essentially is representing the length of one of the legs. So change in x means x sub 2 minus x sub 1 squared, plus now the changes in y to find the other length of the leg for the right triangle, y sub 2 minus y sub 1 squared. Then you're going to label which one's which. So this is my x sub 1's, y sub 1, x sub 2, y sub 2. I'm going to plug it into my formula. Here, x sub 2 is a negative 9 minus an x sub 1, which is 5 squared, plus a y sub 2, which is negative 10, minus a y sub 1, which is a negative 8 squared. So here, don't forget to add the opposite as you're figuring these numbers out while you're computing. I'm going to go ahead and add the opposite, leaving me with a negative 14 squared, plus, if you add the opposite here, that's going to leave you with a negative 2 squared. So now I have d equals the square root of 14 squared is 196, plus negative 2 squared, which is 4, leaving me with d equals the square root of 200. So from this point, hopefully you remember what you're going to need to do to go ahead and round your radical to the nearest tenth. You're going to find those perfect squares, test out some numbers, see which one gets closest to the actual answer. So in this case, to save us some time, I'm going to go ahead and give you the answer. Let's say the square root of 120, So to save you some time, I'm going to go ahead and tell you that the square root of 200 is approximately, let's write this down, 14.1. So to answer the question, how far is the distance between these 2 points? I would say it's 14.1 units. If you have no idea how I got 14.1, there is a lesson that kind of went over those steps. Please refer to that lesson. I will try my best to go ahead and link a video in the description box below. Other than that, now it's your turn. Go ahead and pause the video so that you can try numbers 6 and 7 on your own. Okay, so let's see how well we did for number 6. Hopefully you first wrote down the formula and then went ahead and labeled which one's x sub 1's, y sub 1's, x sub 2, y sub 2's. You plug it into your formula. You're being very careful to check that if there is, you're going to write minus negative. In this case, it wasn't applicable. You should have ended up with negative 2 squared plus negative 6 squared, which leads to 4 plus 36. which then leaves you to d equals the square root of 40, which is not a perfect square, so you're going to have to estimate it to the nearest tenth, leaving you with an answer of approximately 6.3. So a lot of my students are getting everything correct up to this point. The thing that they're messing up on is the actual estimating to the nearest tenth. Please be sure to find a number that's slightly over 40 and one slightly under, so you can really test to see which number is indeed closest. Okay, so now number 7, let's see how well you did. Again, we're going to use the distance formula. We're going to list which ones is the x sub 1s, y sub 1s, x sub 2s, y sub 2s. We're going to plug it into the formula. So notice here you had to be very careful because you did have a minus negative. Hopefully you didn't neglect one of the minus or negatives. We're going to add the opposite just to clean things up, leaving me with d equals 6 squared plus a negative 6 squared, which leaves us with d equals the square root of 36 plus 36. Keep simplifying, d equals the square root of 72. Since that's not a perfect square, you're going to have to round to the nearest tenth. You're going to have to go through the steps, and hopefully you ended up with approximately 8.5. So the distance between these 2 points is approximately 8.5 units. Okay, so now we're going to go ahead and move on to something a little bit with more application of what we just learned. So here it says find the perimeter of the triangle below to the nearest tenth. We know what perimeter is. Perimeter is basically the length of the outline of the shape. So in order to do this, I need to find the length of AB, BC, and CA. So let's first find the distance between A and B. I'm going to go ahead and just label this as x sub 1, y sub 1, x sub 2, y sub 2, and plug it into my distance formula. So here, in order to find the distance, I went ahead and did x sub 2, which is 3, minus x sub 1, which is negative 4. So here we have 3 minus negative 4. Add the opposite there for later. And then I'm going to do x sub 2 minus x sub 1. So 1 minus 0, and you're going to square that. So that's going to leave us with a 7 squared plus 1 squared, leaving us with d equals the square root of 49 plus 1, simplifying that to d equals the square root of 50. I'm just going to go ahead and tell you that the square root of 50 is approximately 7.1. So right now, I'm going to go ahead and say that distance between A and B is approximately 7.1. I'm not done. I have the distance of one of the sides. I need to keep going. So let's go ahead and find the distance of BC. So once again, you're going to have to label the points. This is x sub 1, y sub 1, x sub 2, y sub 2. So here we have our formula in the form of x sub 2 is, actually this one's reversed, so let me just explain this to you real quick. It does not matter which you label as x sub 1 or x sub 2. No matter which way you do it, you're still going to end up with the same answer, but just so that it correlates with the work shown here, I'm just going to call this x sub 2, y sub 2, x sub 1, y sub 1. So here we have x sub 2 minus x sub 1, and then y sub 2 minus y sub 1. Here you have to be careful. 1 minus a negative 5. Add the opposite, leaving us with the square root of 1 squared plus 6 squared simplifies to the square root of 1 plus 36, which simplifies to the square root of 36, which is square root of 37, which is approximately 6.1. So I'm going to go ahead and mark that this length here is approximately 6.1. So we're almost there. We just now need to find the distance between A and C. So here, I'm going to go ahead and call this x sub 1, y sub 1, x sub 2, y sub 2. So here you're going to do x sub 2, negative 4, minus 2, and then y sub 2, which is 0, minus negative 5. So again, you have to put minus negative. Here we're just going to add the opposite to help us out, which leaves us with 6 squared plus 5 squared simplifies to the square root of 36 plus 25, simplifying to the square root of 61, which is approximately 7.8. So now that I know the lengths of the three given segments, I can go ahead and find the perimeter by adding all three side lengths together. So the perimeter is approximately 7.1 plus 6.1 plus 7.8, which is going to be approximately 21.0. So that is actually going to conclude the lesson for today. However, I do want to mention one thing first. So the distance formula is a little intimidating because there's quite a bit of memorization involved. So what should you do if you're completely lost? Real quick, I'm just going to give you an example of an order pair, maybe 4, 7 and -3, -1. What could we do in a case like this? First, you need to understand the distance formula is yet again derived from the Pythagorean theorem. Okay, so here what you're trying to do is find the height of a triangle and the length of a triangle. So here, the height is represented by the change in y. How come? Because the y is the axis that runs up and down. So here, in order to find the height of the triangle, you're going to see how did 7 become -1? Well, in order for 7 to become a -1, you'd have to subtract 8. But let's think for a second. Is it possible for a length to be negative? No. So when we're simply talking about distance, it doesn't matter the direction, it just matters how far did it move. So in this case, I would say the height is 8. Then what we're going to do is find the length. So in order to find the length, which runs on the x-axis, I'm going to go ahead and take a close look at the x-coordinates. So in other words, how did a 4 become a -3? Well, in order for this to happen, you had to subtract 7. So again, since there's no such thing as a negative distance, you're going to have to go ahead and consider that as a distance of 7. Once you have that, you technically have a right triangle, and you're able to solve using the Pythagorean theorem, because that's what the distance formula is derived from. So this here is going to, I'm just going to call this C since that's the hypotenuse. It's going to leave me with 8 squared plus 7 squared equals C squared. So 64 plus 49 equals C squared. That's going to leave me with, let's see, 113 equals C squared. Take the square root of both sides. So I'm going to say C equals the square root of 113, which is approximately, let's check that out. The square root of 113 is approximately 10.6. So I wouldn't suggest this for you to use all the time, but this is a very good, simple way to think of the distance formula if you're completely lost and you forgot what you need to do. This is your backup plan. This is your backup plan. Just an alternative way of doing it. Definitely practice the distance formula because that's what's going to get you pretty far with any types of number that we can throw at you. So yet again, thank you so much for tuning in, and as always, until next time, bye.